Okay, so let's get started with IAM. So there's a lot of things you should know about IAM. You should be knowing about IAM already. So I'm not gonna go over the basics. I will just try to remind you what it is. So users have long-term credentials. Users have long-term credentials, and therefore you are AWS users. So you can group them, and you can also define roles which are going to be short-term credentials, and then use the STS service to endorse these roles and get credentials that are going to be temporary, or those to do the actions that the roles are authorized to do. A specific kind of role we have been seeing all along the courses in is the EC2 instance role, where it is going to use the EC2 metadata service to get the short-term credentials on an EC2 instance, and you can assign only one role at a time for the instance. By this way, your instance can access, for example, an S3 bucket or a DynamoDB table and so on. There's also service roles which are assigned to services directly. So if you have a service such as an API gateway or code deployer that needs to do an action or an auto scaling group or a Lambda function or something else, then that service needs to have a role, and that role needs to be able to be provisioned to do all the actions that it needs. Okay, okay. Then finally we have cross account roles. Then finally we have the cross account roles, and these roles are going to be really helpful in case you need to access another account to perform actions in that account. You never share users credentials cross account. You always allow to assume roles, and we'll see this in the details in this course. Now you have policies. Now you have policies in IAM, and that will define a role a user can do. Define a user can do, and so you have three kinds. You have AWS Managed Policies, which is policies defined by AWS, and that are going to be changing over time. Maybe but they will do something very specific. Customer Managed, which is you creating these policies, and you can assign them to multiple users or multiple roles, and you can make them evolve over time, version them, or third one is the inline policy, which are going to be policies assigned to one specific user or one specific role, and you can make them evolve over time, but you cannot share them across users or across roles. And finally, we will do a discussion on resource-based policies. So this is when you have an S3 bucket policy or an SQS query policy and so on. So which would allow us to perform some really interesting patterns, and we'll see this in the lecture. So what does an IAM policy look like? Well, first of all, it's going to be a JSON document, and that they will have four things or five things. And those will have four things and five things: effect, actions, resource, conditions, and sometimes in it, policy variables. So we'll do a deep dive in all of these, but the idea is that a JSON policy looks like this. JSON policies look like this, and then we have some statements, For example, allow EC to attach volume, EC to detach volume on the resource, which is all EC2 instances, and the condition is like string equals resource type, department development. That means that only the EC2 instances tagged with this tag can be attached or detached to volume and so on. So this is quite a specific, and you can get very crazy with IAM policies, but this is how all of the AWS works, and we know this already. If there is an explicit deny in your IAM policy, then it will have precedence over any allow, and so that means that explicit denies always have the highest priority. And we have a lecture exactly to understand how IAM policies and everything else are evaluated in order. Okay, so the best practice, we know this already, is to use the list privilege for maximum security. List privilege for maximum security. That means that you need to make sure that IAM policies are allowed just to do what they need to be doing and not more. Some tools we can use to make sure that this is case that there is a IAM access advisor. where you can see all the permissions you have granted to an IAM policy, and that last time each of these permissions was last accept. So in case you have a policy or something that was not used for a year, maybe it's worth removing it from IAM policy to ensure there is less privilege. Okay, another one is going to be the access analyzer, and this is to analyze resources or shared with external entities, for example S3 buckets, and this will allow you to look at if another accounts have access to your S3 bucket. Maybe that's something you are not expecting here, and you want to make sure to log down the S3 bucket. Okay, if you are not very familiar with IAM policy, I would encourage you to look at the AWS documentation and go through this URL to make sure you look at few of them and understand them better. But I would assume that by now you know that they look like already how they work. A few IAM policies we'll get across to be the administrator access policy, which is going to be, which is meaning that everything should be allowed on any resource. So this is a policy you have to specify. So by default, if you set anything in IAM policy, then everything will be denied. So what I said, like if you set anything in an IAM policy, then everything will be denied. But if you add a statement which is allow action star, allow action star, allow action star resource star, or allow action star resource star, then you will be giving the administrator access, and then everything will be allowed. And because this is something very common for administrator, AWS provides this as a managed policy. So the another very interesting policy, a bit less privileged, is called the AWS Powered User Access. You will be using this policy throughout your experience or throughout development. And so, so in the first one, the effect is allow. In the first one, the effect is allow, not action, not action. Okay, so you will be on IAM star organization, and account star for resource stars. Account star for resource star. And also it's going to allow still a few IAM actions such as create service link role, delete service link role, list roles, describe organization, list reasons. So you may be asking, me like why the left hand side is not action used and not just effect deny. So if you use effect deny, then you specify that these three actions, then you specify these three actions, and then you specify effect allow, then these five actions that is available on the left, these five actions will automatically be denied because there will be an explicit deny on the left of hand side. Okay, so here we have a very interesting use case in case we don't want to deny everything in there, because we want to explicit allow a few things in there. Then we can use the not action instead of deny to allow for these two things to coexist together. Okay, now next is the conditions in IAM policies. So this is what a condition would look like. So we have a condition operator, a condition key, and a condition value. And so we can do a lot of crazy things with conditions. The first one is going to be a string operator. So for example, you are saying I want my principal tag to be job category. I am user admin. So this is when you look at tags, or you can look at, for example, on this prefix for this pre-bucket policy to say that we want the users to only access a specific home directory. There's numeric operators where we can look at it, is it equal or like equal then or not equal, and so on. Dates to look at, compare dates. This is very helpful when you want to provide temporary access to a specific service. Booleans, which is going to be really helpful, for example, if you want to evaluate a SSL, such as secure transport colon true. Okay, so and also when you want to look at MFA using multi-factor authentication present true on a certain user or certain account. So there's also an IP address condition or not IP address condition, and these conditions will really helpful for buckets, S3 bucket policies, for example, or any kind of policies. You want to ensure that only a specific kind of source IP can access the service. So we can have an IP address, source IP equals, and we have a CIDR block /24. And finally, we can look at ARN equals, ARN like, and the null conditions. So we are also checking if something is null or not. Now, right now, I just wanna reassure you. You don't have to remember all these things. Okay, I just want to show these things exist with the IAM policies when you will be drafting these IAM policies, so that you can have very specific IAM policies, such as if the exam is asking you to use an IAM policy as an answer to a problem, this would be possible instead of using, for example, a custom script. Okay, so but you don't remember exactly all these things, exact conditions, and so on. Okay, so next we have, there is the policy variables, IAM policy variables and tags, and these are really powerful. Once we have seen in the dollar sign, AWS username, and this is most commonly used, for example, in S3 bucket policy. So we have resource minus S3 bucket slash the variable AWS username slash star. And what this does is that it will look your username to perform actions, all the actions on just the prefix that starts with AWS username. And so that means that every user will have its own little directory in your S3 bucket, and that is very common usage for this. There is some specific policy variable and tags, for example, current time, token issue time, principal type, secure transport, which is for SSL, source IP, user ID, and source instance ARN. And these are provided by AWS. So their services, specific policy roles and tags, for example, S3 prefix, max keys, SNS endpoint, SNS protocol. And finally, you can have tag-based policy variables. For example, if you use resource tag slash key name or principal tag slash key name and so on, so you can start having some really powerful IAM policies. And this is why I would encourage you to use the link from before I've included in the slide, to just look at few of them and try to understand them, so you can really see whole range of what can be done with in IAM. Okay, more importantly and more exam focused is going to be difference of IAM roles and resource based policies. So, and it may not be very clear exactly what the difference is, but there is a very clear difference. So we have two options, right? We can attach a policy to resource. We can attach a policy to resource, for example, in S3 bucket, versus attaching of using a role as a resource. For example, in S3 bucket versus attaching, so here is an example I have been given. So we have a user in account A and is trying to access an S3 bucket in account B. But now there's two ways of doing this, right? The first one is to use a role in account B, and we will be assuming that role from account A. And once you assume the role in account B, the role will have the necessary permission to access the S3 buckets, and that works. And another option is to use an S3 bucket policy, and the S3 bucket policy, we are saying, okay, S3 bucket policy, okay, user, we are saying, okay, user in account A can access my Amazon S3 bucket in account B, and both of these solutions allow users on account A to access Amazon S3 bucket in account B. But there is a very big difference. What is it? Is that when you assume a role, whether it is a user, an application, or a service, you are going to give up all your original permissions, and you are going to take the permission assigned to the role. So that means that when we do assume the role, the accounts B, the orange situation, when the user in account A gives up all his permission in account A, while it's being assuming a role in account B. So the idea is, when you assume a role as a user application or a service, then you are going to give up your original permissions and you are going to take the permission assigned to the role. And when you are using on the contrary, or like a resource-based policy, then principal does not have to give up any permission. So when do we use resource-based policy? Well, here is an complex example. An example. So we have a user in account A that needs to scan a DynamoDB table in account A. It's have to extend a DynamoDB in account A, so its own account, but then dump the content of it in S3 bucket in account B. So as you can see, the user needs to operate on two accounts. Well, in this case, we need an IAM role in account A to make it happen, and also resource policy on the S3 bucket and account B to make it happen. So this is very good use case for resource-based policies. So resource-based policies are supported by so many AWS services and is increasing for example, Amazon industry buckets, SNS topics, SQS queries, Lambda function, ECR, backup services, EFS, Elastic File System, Glacier, Cloud9, AWS, IDE, Cloud9. I mean, you'll see the list here. It's pretty much supported by most of the important services resources in AWS. Now let's talk about IAM permission boundaries. So we know that there are some permission boundaries that are supported for users and roles, but not groups. This is an advanced feature that is going to allow you to set the maximum permissions an IAM entity can get. So as an example is going to be way easier. For example, say we attached this IAM permission boundary, so saying S3 star, S3 colon star IAM permission boundary, Clover star, and issue star, and this IAM permission. So through this IAM policy, we just allow IAM create user star. Okay, so well, these two things together will mix up, and then what will happen is that there will be no permission. Well, because even though the action IAM create user is authorized on the right hand side, because the IAM permission boundaries only allow the permission on S3 CloudWatch, and the EC2 when the user 0 will have no permission. So IAM permission boundaries can also be used with the AWS organizations. SCP. So if you look at the SCP in the middle, we have the intersections of the SCP, the permission boundary, and the identity based policy. So you would use IAM permission boundaries when you want to delegate responsibility to non-administrator within their permission boundaries. So for example, create new IAM users and to allow developers to self-assign policy or to themselves and to manage their own permissions while making sure that they can only do these things within their privileged rights, so they cannot escalate themselves. And it's also very useful to restrict to one specific user instead of using a whole account restrictions with organizations and SCP. So that's it for IAM. I hopefully you know most of these things, and I will see you in the next lecture. Go through the links that I've included in this these slides. Thank you.